Okay, everyone, let's get started. Thank you all for coming to today's Global Health Special Seminar, the Ebola Outbreak, How to Move Forward from Here. I'm Stuart Gilmore, Assistant Professor in the Department of Global Health Policy. I'm here to introduce today. This seminar is organised by the Department of Global Health Policy, the University of Tokyo, the Africa Society of Japan, and the Institute of Scientific and Industrial Research in Osaka. So first, Professor Shibuya is going to give us some opening remarks. Thank you, everyone.
Yeah, just a very warm welcome to the Global Health Seminar tonight, organized by the University of Tokyo and the Japan Society for Africa. A month ago, we had a seminar on the Ebola outbreak by Professor Peter Pia, who co-discovered the virus in 1976 in Zaire. Professor Pia described the current Ebola outbreak as a humanitarian crisis. But we do have some hope to tackle the current crisis. After 4 decades since Peter Pia and his colleagues discovered the virus, there is much progress in scientific understanding of the virus. Today I am very excited to welcome Dr. Sina Bavari, who is Chief Scientific Officer at the USAMRIID Research Institute of Infectious Diseases. I really look forward to an inspiring and informative lecture, and I do hope that you will enjoy it. Thank you very much.
So, thank you all for coming to the seminar, and I appreciate the hospitality here and invitation to share some of my thoughts and understanding of what I'm thinking about this outbreak and how I think this outbreak is going forward now. My name is Sina Bavari. I'm at the US Army Medical Research Institute of Infectious Diseases, better known as USAMRIID. We're in Frederick, Maryland, just about 45 minutes drive outside of Washington, D.C. I'm Chief Science Officer there and a Scientific Director. There is my email. Please don't hesitate to contact me. That doesn't mean I'm going to get back to you, but don't hesitate to contact me. Okay, so there are some acknowledgements here. First of all, I got to really give it to Kenji and his team for supporting what you're having here, putting the seminars together, and Mr. Goda, Kimura, and Murakushi for actually supporting me coming in here and talking to you all, and World Health Organization for actually lending me a lot of their slides, and USAMRIID for allowing me to be here and talk to you all. So this is just a little bit about USAMRIID and what we do. USAMRIID's vision is to actually to be the leader in advancing medical technology and biodefense to and be experts in areas that would actually help our military forces and the nation. The mission statement is really to provide leading-edge medical capabilities to deter and defend against emerging and current biological threat agents. And my second acknowledgement should go to actually tremendous sacrifices that's been made by a lot of people who work in Ebola response, and especially to all the people who've been involved in the patient care. These people actually been putting their lives at jeopardy to take care of patients. So the seminar outline is going to be, as mentioned in here, is first I'm going to give you a quick update, and my update is about a couple of weeks old, and I haven't really gone back to revamp my slides yet, but it actually shows you where we are right now. I'll discuss a little bit about what is, what are the filoviruses, especially Ebola and Marburg, and then why is Ebola virus so lethal? I'll say a little bit about the immunopathology of it. Then I'll tell you a little bit about how infectious Ebola virus is compared to other viruses like influenza and HIV, for example. This is really important. What is the reservoir of the virus? Really understanding something about the reservoir can tell us quite a bit about how the virus is transferring from one area to another area. and how can we actually stop the transmission of the virus also. This could be the key. Then I want to discuss a little bit about why did this current outbreak got so big so quickly. And I'll move into the transmission of the virus. There's a lot of discussions about the aerosol transmission of the Ebola, of the current Ebola outbreak can be actually by aerosol transmission. And I hope by the time I end up with the seminar, you'll get a feeling that this is probably not the case. Then we're going to discuss a little bit about how do we stop this virus from spreading, mainly really by using vaccines, therapeutics, and some typical hygiene. If you have any questions, please stop me and ask the questions. Otherwise, you will forget at the end, and I'm getting Sina, so I'll probably forget about what I said. So just stop me and ask the question. So first, we're going to discuss about just an update of the current situation. So this is obviously one of the biggest outbreaks that we've been dealing with. The past 23 outbreaks, all the numbers together, combined together, is a little bit less than 2,400. Till now, till about November timeframe, and actually currently now there are more than 6,000 deaths and about 17,000 cases. Okay. The virus has been spreading between mainly 3 countries, Sierra Leone, Guinea, and Liberia. And now actually has infiltrated into other countries such as Mali and Cote d'Ivoire. This just gives you a little bit of idea of the signs and symptoms. The black bars are the fatal cases, the lighter bars are the non-fatal cases. This shows that if you have diarrhea or vomiting, you tend to die. Okay. And if you're somebody like me, over age of 40, and if you catch the Ebola virus, your situation is pretty desperate. If you're over 40, you tend to make it. Okay. These are really pretty distinct bars from each other. You don't need a lot of statistics to look at these. So as I said, the current outbreak is between mainly 3 countries are listed in here, and the current death rate is close to about 6,000. This just shows the numbers actually from November. They've revised these numbers, and the outbreak center is between these 3 countries. But as you can see, the border seems like to be stopping this outbreak from going into Mali or going into Cote d'Ivoire, which is actually not the case. Now they're finding cases in Cote d'Ivoire and Mali. Sorry about the quality of the slide, but really this shows the number of cases since we started per week. And it seemed like at least in Guinea, these numbers are plateauing. In Liberia, it seems like the numbers are actually dropping. And in Sierra Leone, it seems like the numbers are actually plateauing also. But there's an issue here. The issue is that there are about 4,000 to 5,000 burials a week in these 3 countries that are totally unexplained. So maybe those numbers are not the true numbers, maybe they are the true numbers, but somehow we have to explain why there are so many burials without any explanation. Okay, so next I'd like to talk to you a little bit about what are filoviruses, and I'll just concentrate Ebola and Marburg. So Ebola and Marburg, they belong to the family of filoviruses. These viruses are, the natural reservoir is really unknown, although bats have been implicated, mainly for Marburg virus, but there's still a lot to really understand about the reservoir. They're negative strand, non-segmented RNA virus. They induce severe hemorrhagic fever. The death rate is 70 to 90% depending on the outbreak. The current outbreak and the current death rate in the outbreak is probably closer to 65 to 70%. These they belong to, they actually fatally associated with the impaired immune system. There's no vaccines or chemotherapeutic available. They've been implicated to be used or to be weaponized by former Soviet Union. These are emerging infectious diseases. There is a rising number and intensity of the outbreaks, as you can see by the current outbreak. Then we're really interested to understand how can the immune system actually fail to deal with this virus? And does this really tell us something about the future viruses and the future emerging diseases that are coming up? And for us, this is a serious threat to Department of Defense members, researchers, laboratory workers, healthcare professionals. That's why we are interested in working on this. This is just to show you, as I said before, former Soviet Union was working on Ebola virus and Marburg viruses as a bioweapon. And this shows the sites of the former Soviet Union. And you can see the numbers of people who are actually working on in bioweaponization of different agents, including Marburg virus. Close to 60,000 people at the peak of the bioweapon program, they were working on this material. So I'm just going to say a few things about Ebola virus and Marburg virus. These are negative strand RNA viruses. That means they go from a 3' to 5'. There are only about 7 genes in here. So it's amazing how 7 genes can actually overcome about more than 25 genes that human genome has. There are a few genes in here, a few proteins that I like to concentrate on. Mainly, I like to discuss a little bit about the BP24 gene in here, which actually turns down your innate immune responses, mainly the interferon responses. The other one is BP35 gene also that knocks down the interferon responses. So this allows the virus to grow rapidly within sentinel cells that are critical for immune responses, such as dendritic cells, macrophages, and monocytes. The actual receptor for the virus is really not known, but there's been a lot of thought about how some of these factors, some of the host factors can actually be the co-receptors or maybe co-ligand for the receptors, but the actual receptor is not known. There is reported in Nature that NPC1 it could be one of those factors that actually allows the virus to fuse to the membrane and get into endosomal part of the cells. So why is Ebola virus so lethal then? Really has a lot to do with the immunopathology of the virus, and in a typical productive immune responses, dendritic cell picks up the virus or picks up the protein. This gets then you get an activated dendritic cell. Then this dendritic cell can easily communicate with natural killer cells, B cells, T cells, to produce what I call a productive and protective immunity. How about in the case of Ebola virus? In the case of Ebola virus and Marburg viruses, these cells actually infect dendritic cells, as you can tell in this picture in here. And they grow to a large amount in both in viral cells and in human dendritic cells. And then when they infect human dendritic cells actually become quiescent. They don't really do anything. They don't respond to the virus. This is one of the major issues. Not just dendritic cells that don't respond to the virus, but human natural killer cells, although they're not infected, but they're actually depleted from the system, and they don't respond to the virus. NK cells and other cells, such as T cells, are depleted from circulation rapidly. This actually leads to the demise of the host. Neutrophils, on the other hand, are pathologically actually activated. So that leads to the cytokine storm late during infection. what actually happens to a lot of the other immune cells, such as gamma delta T cells or other polymorphonuclear cells, the answer is still out there. We still really don't have to fully appreciate that. So this is just in summary, tells you a little bit about what happens when Ebola virus clashes with innate immune system. So the dendritic cells, that what I told you about, these are the sentinel immune cells. They get infected by the virus. They don't really produce interferon. They don't produce any other cells to bring in other T cells or B cells to the area to alert them from the virus to the virus. This actually leads to inhibition of CD4 and CD8 cells, leads to premature death of these cells, and poor immune responses, and expansion of the virus, which leads to high viremia, high infectivity of the cells and tissue late in the disease. On the other hand, monocytes and other key elements of the innate immune cells, they're not really activated. They don't produce TNF or IL-6 or other factors early in infection. This actually leads to, and they move around, so they infect other cells such as hepatocytes. This leads to organ failure, hemorrhage. And on the other hand, you have neutrophils that are pathologically activated. This actually leads to uncontrolled inflammatory responses and inflammation. Adds to endothelial leakage, rash that you typically see, and hemorrhage. And all of that end up in what I call a gathering of hemorrhagic fever virus storm, which increases viral burden, direct damage to the tissue, demise of the immune responses, and unwanted inflammation, which is referred to as, in late stages of the disease, refers to as cytokine storm. How infectious is the virus, Ebola virus, compared to other viruses? And this is just a cartoon to show you the infectivity of Ebola virus compared to such thing as like influenza virus. Okay. So if you have about 10,000 or 1,000 influenza particle that induces infection, HIV is about 100, about 10 times lower. And in case of Ebola, all you need is a single infectious particle to induce the infection. Okay? So that means if you're starting, for example, at, let's say, 1 million plaque-forming unit, you can reduce that down to 99.99%, which is really good. You're still going to end up with 10 to 100 plaque-forming unit. All you need is single influenza virus to induce the infection. Actually, each one of the plaque-forming units, there are about 30 to 300 viruses there that can induce infection. Typically, in a non-human primate, a single infectious particle ends up in a lethal case. Okay, so what are the reservoir? What is the reservoir? There has been a lot of debate about what the reservoir is, from bats to deer to gorillas. And there are a lot of, as I said, there are a lot of debates on what the reservoir is. And it's probably not non-human primates because they tend to die following infection. Bats they've been implicated, different kind of bats been implicated during infection. Actually, few of the caves that, for example, Marburg virus started, one of them is called Python cave. That one actually, pythons actually stand outside of the cave, and as the bats are coming out of the cave, they grab them and they eat the bats. These bats are infected. Now, most likely they have infected the python. So one idea is maybe snakes could be the reservoir. Okay? There's a lot of debates that we are actually looking at this. These are very challenging studies to do in BSL-4, for example, to look to see how snakes are actually, could possibly be the reservoir. So different bats, as I said, have been implicated, and the other creatures that have been implicated are just a mouse. Okay? That the dropping of the bats could be taken up by mouse also. And these guys happen to be, the pythons could be feeding on the mouse also, so this could be another transmission route. So we're looking at that, and a lot of other people are looking at this. So now I'd like to actually move a little bit into the outbreak itself, and how did this outbreak, the current outbreak, how did it get to be so big so quickly? Why did it get out of hand? First of all, the outbreak actually happened in the west part of Africa where they'd never really seen Ebola virus before. Okay? And the healthcare community was totally unprepared to deal with this. They had high level of community exposure through household care that was given to the patients. The other issue was actually the customary burial procedures that is actually been implemented in West Africa. So after the person dies with Ebola virus, they wash the body and then they drink the water that come off that patient. So now everybody who drank that, they all got infected also, obviously. Okay. So those type of customs that they need to be education. A lot of education has to go to this to make sure this is stopped. There is a close community ties across the border areas that are actually impacting the care seeking behavior and contact tracing. This has been very, very difficult to do in Liberia and Sierra Leone. And there's been really lack of enormous commitment that really needs to stop this outbreak from communities within Sierra Leone, Liberia, and Guinea also. And as you can see, the area is very, very difficult to get around it. So it's very difficult to go from one area to another area for both treatment, diagnostics, vaccine, if you're thinking about that also, and just to get around in general. The other area has been really lack of culture of self-protection of healthcare workers. This is a typical Ebola treatment unit. As you can see how bad the situation is. Within the Ebola treatment unit, you can see an IV line hanging out, a lot of blood laying around. So all of this are the source of further infection for the healthcare workers. Usually the protective gears, as soon as they come out, it actually get dumped on the floor someplace, so the virus tends to thrive in these areas and stays around for a long time. Right outside of the Ebola treatment unit, this is what you typically see, the pile of what you just saw inside. They're just been thrown outside and it just gathers there for a week or so till somebody comes by. And the water that actually drains from that, but after rains and so on, so now you get other infection going on also because you're probably infecting mice and other things that are coming over. So the other major areas being that between Guinea, Liberia, and Sierra Leone, for about 300,000 patients, you only had 4 medical doctors to take care of them. So this is a huge, desperate number. From these 4 doctors, half of them are died, or have actually died from Ebola virus. So now this number is about 2 per 300,000. Okay, as I told you something about the burial also, the burial practices now has been changing, but you can see this guy in here without a mask, without a glove, and he probably was touching the body before this. So this guy was probably infected now. So the inadequate healthcare infrastructure for supporting and implementing typical standard care has been missing. Inadequate access to soap and water, alcohol-based hand rubs, over-reliance really on bleach use as a hand rinsing. This has been a really bad practice there. And that's mainly because of inadequate access to soap and water. Inadequate access to sharp disposal boxes actually has ended up in a lot of other needle stick injuries that has caused more infection. Irrational use of protective gears, inadequate health facility triage procedures, lack of awareness of presenting symptoms, for example. They didn't have decent diagnostics to tell different diseases apart. So if somebody was infected with malaria and had a fever, they would put him immediately into an Ebola treatment unit. Now he's infected with Ebola also. So how the virus actually gets transmitted? So these are the typical and known virus transmission that happens by oral route, conjunctival route, respiratory route, intramuscular route, intraperitoneal route, and submucosal. The epidemiology actually suggests that there's mainly direct contact with body fluid, respiratory droplets, and this is not aerosol, these are large droplets that I'm talking about, blood, reuse of needles. In these cases, the death rate is about 100%. Okay, so how does the virus actually get transmitted again? So these are direct, through direct contact through bodily fluid. This is most likely the mode of transmission for many of these. The virus is actually present at very high titer in blood, diarrhea, and vomit. So when somebody vomits and you happen to be standing around, or it's a bus that's filled with people, you can imagine that everybody in that bus probably got infected also. There is a high risk, obviously, of sharing needles, handling the deceased, or caring for the ill patients. These are all can be routes of transmission. Large droplets, as I told you, is another. It's another major route. This is likely mode of transmission, supported by a lot of epidemiology data that can account for infections without direct contact. Virus is actually acquired by proximity to the patient or touching a contaminated surface. The virus is present at very high concentration, as I told you about, in blood, diarrhea, and saliva at the middle to end of the infection. It is actually unknown if human activities make large infection droplets worse or not. How far do the droplets really travel? Is really a lot of questions right now that we're asking. We know this is not really by true aerosol transmission, but the droplets can actually travel maybe about 1 or 2 feet, and then they're going to drop out, and they're going to be on the floor. So this is not what I would call a true aerosol transmission. Contaminated surfaces is another one that it's been talked about quite a bit, but that's probably less likely because the virus really doesn't survive that long on the surfaces. Because the sunlight, humidities, all of that can actually affect the virus glycoprotein. And this virus, because of the coat that it has, it's quickly degraded. There are actually absolutely no documented cases of aerosol transmission of the virus. Okay. That's very, very important. This is really highly unlikely because it only happens in laboratory and it doesn't really happen in a context of naturally occurring Ebola virus. So there are a lot of questions actually that still exist about the stability of the airborne virus and in tropical climate, how long the virus can stick around on the surfaces, for example. So how do we really stop the virus from spreading? So immediately have to actually identify the infected individuals. Obviously, use of vaccines and therapeutics can slow down the virus transmission. Educate the public through society engagement. This is probably one of the most important things we can do right now. So education is critical. Enhance the healthcare standard in those countries. The other one is really identify the reservoir of this virus. Putting on the protective gear is very important. Taking off the protective gear is probably far more important than you putting it on. Taking off the protective gear is actually how a lot of the virus transmission has occurred also. So, are there vaccines and therapeutics that are coming out against Ebola virus? The answer is yes. And if you look at the viral life cycle, viral entry, viral fusion, and replication process, transcription and translation, all the way to budding, every one of these stages can therapeutically be monitored and therapeutically can be actually targeted. Here actually I'm identifying almost all the areas of viral life cycle, from cell attachment, receptor binding to internalization, to fusion and uncoating, to transcription translation of the virus, polyprotein processing, replication, assembly and trafficking, and to release of the virus. Each one of these steps can actually therapeutically be monitored and therapeutically targeted. So what are the potential anti-Ebola therapeutic ways that we can go after the virus? I'm breaking these into two. One would be direct antivirals. The second one would be post-response modifiers. So the direct antivirals, I'm breaking them up into two categories. The first one is the synthetic molecules, and the second one is biologics. Sorry, there's a lot of writing in here, but so I'm breaking down the potential anti-Ebola therapeutics, antivirals, as I told you, into two categories. One would be direct synthetic molecules, the other one would be direct, but these are biologics. In synthetic molecules, we've actually been working and we actually have a lot of data now accumulated on siRNA, antisenses, which are morpholino oligomers, PMOs. And so these are what I call nucleic acid-based technologies. So these are fairly direct acting, and they target the virus at specific sites, and they either stop the translation or they stop the replication of the virus. Then we have small molecules. These are direct antivirals. These I would break them up into polymerase inhibitors or non-polymerase inhibitors. The polymerase inhibitors, I'm pretty sure all of you are well familiar with T705 favipiravir. This was actually, these were found by Toyama. This is where the T comes from, in Japan. And is currently in phase 3 clinical trial studies in US against influenza virus. And it's already been approved in Japan against influenza virus, the exotic forms of influenza virus. We're doing a lot of studies on trying to see the effect of T705 on Ebola virus. What I can tell you, T705 has elicited dose-dependent viral knockdown in non-human primates. More efficacy data are actually on their way right now. The other synthetic molecules, these are non-polymerase inhibitors, so they don't bind in the replication side of the virus, but they inhibit VP24, for example, function, VP40 oligomerization, or they inhibit the replication complexes. On antiviral direct, but these are the biologic side. There are interferons. At least in our hand, in other people's hand, interferons has shown to only extend the life, but not really cure the virus. And biologics such as interferons are very, very difficult to administer because you're not really sure when to administer. Do you administer them pre-exposure? They lose efficacy a day or two after exposure, so you have to really be careful when you're exposing the patient. Then there are direct-acting antibodies. These are famous ZMAP antibodies that you probably have heard of. Then there are a lot of blood products also, convalescent serums, plasma, platelets, and so on. Then there are a lot of ways you can imagine that you can actually target the viral entry or the fusion to inhibit NPC1 or catapsins that are needed for the glycoprotein breakdown, so it can actually fuse to the membrane. So catapsin directly can be targeted also. On post-response modifiers, these are, I would call them such as compounds that will actually inhibit or act on coagulopathy pathways, such as NAPC2, for example. They've shown to be partially protective in non-human primates if given very, very early infection. Again, like a lot of other biologics, these are very difficult to monitor. You're not really exactly sure when to give these compounds. Other small molecules, such as kinase inhibitors, so most of the viral proteins are phosphorylated. These viruses have very, very small genomes, so they don't really come equipped with their own kinases. They use host kinases to phosphorylate them. So kinase inhibitors can be used in this case also to inhibit those phosphorylation events. Anti-cytokines or chemokines can actually be actually introduced into the patient also, but again, the problem is when we really administer these products. And we really have to understand something about pharmacokinetic and pharmacodynamic relationship of these anti-cytokines and anti-chemokines to be able to really use them effectively in human beings. Then on the side of vaccines, I've broken down the vaccines into 4 categories. These are live replicating vaccines, vector-based vaccines, genetic vaccines, and protein-based vaccines. In a live replicating vaccines, VSV, vesicular stomatitis virus, right now is in phase 1 clinical studies against Ebola virus. Rabies virus, it's another one, it's a live attenuated rabies virus. That's in the preclinical stages right now. And there are a few other ones also that I'm neglecting to mention. On the vector-based vaccines, human adenovirus, that's in the phase 1 clinical studies, both in US and in Africa. And chimp adenovirus also is in phase 1 clinical studies. I think this is started in Africa also. The other one is Venezuelan replicon. These are in preclinical, near phase 1 clinical studies. So these vector-based vaccines tend to go through one round of replication and then they die off, versus the live attenuated vaccine that they go through several rounds of replication. There are genetic vaccines, DNA-based or RNA-based. The DNA-based are in phase 1 clinical studies. The NHP, that non-human primate efficacy, is really undetermined and is really, or in some cases, they've been non-efficacious. Human immunogenicity is really uncertain for these DNA vaccines. And the RNA-based vaccines, they're really still at the discovery phases. The last stages would be protein-based vaccines. These are like virus-like particles. This is something that actually came out of our lab. These are in the preclinical stages. They're getting very close to going into phase 1 clinical studies now. Purified glycoprotein, with or without different flags, such as FCs, and with multiple different adjuvants. These are still at the preclinical stages. So, in conclusions, Ebola virus is extremely infectious, but not really easily transmitted. And if you really think about the cases in the United States, for example, Duncan, the person actually died from the Ebola virus that came from Liberia. He really didn't infect anybody. Although he was at home for many days, he didn't really infect anybody at home like that. This really tells you that this virus is not that transmissible, at least within a setting of Western cultures. There are really no documented cases for aerosol transmission of the virus. Although Ebola virus changes naturally as it's going from one patient, one carrier to another carrier, one person to another person, but these changes are not really that extensive that would force the virus to be aerosolized. So the virus actually has to change substantially to become aerosolized. One way to think about it, coronaviruses and influenza virus are around. They tend to twill and then move quite a bit. Ebola virus is fairly long, elongated, with a really ugly head. Okay? It tends not to really go that far. So there are really a lot of diagnostics that I didn't talk about. Many vaccines and therapeutics are coming out. Ebola and other hemorrhagic fever viruses have actually potential to be used as bioweapons. And I can promise you that probably this will not be the last outbreak of these type of viruses. You're probably going to have a lot more outbreaks like this one coming up within Africa and other regions also. And not just Ebola, but other hemorrhagic fever viruses also. And thank you very much for attending this seminar.
Thank you, Dr. Bavari, for a very interesting and comprehensive presentation. It was very interesting to watch. So we're going to have a reasonably relaxed period of Q&A now, some questions. So what I'd like you to do, we have a few people with microphones. We have Alex over here, and we have someone over here as well. So just raise your hand if you have a question. And when you give your question, please first give your name and your affiliation, so where you're from, and try to be brief and concise if possible. And if you have a question in Japanese, we do have someone who will attempt to translate it for the audience and for Dr. Bavari. She's sitting just here. So questions, please. Yes, over here.
Thank you very much for an excellent presentation. I'm Ariano from the University of Tsukuba, an infectious disease physician. I have a question about infection control that should be implemented in Japanese hospitals. Do you have any suggestions for that?
Oh, I'm not familiar with Japanese
my question.
infectious disease control. But so let me put it this way: when you're not ready for it, and a good case would be the Dallas case. That can be a disaster. People get infected. If you're ready for it, like University of Nebraska Medical Center was, and they absolutely have had no problem. So they really followed what I would call a strict infection control. They actually have autoclaves that's attached to the exit places, so they can actually autoclave everything as it's leaving. Everybody who was leaving the ward was actually taking a shower as they were leaving the ward also. That's a good way of actually controlling the infection. I'm not sure if I'm answering your question or not, but.
My question is, we have a difficulty to handle with a patient who sort of suspected Ebola virus disease. And my question to you is, do we really have to wear that expensive personal protective equipment to deal with the suspected patients?
Well, there are ways that you can easily actually infect yourself. For example, if you don't really understand how to take your PPE off, that's a good way of getting yourself infected. If you don't really understand the basic criteria for infection control, that's another good way of getting yourself infected. In a hospital setting, when you have patients that are at their peak of infection, they could easily have 10 to the 8th or 10 to the 9th plaque-forming unit of the virus in their vomit, in their blood. Slightest mistakes there could be devastating. So wearing the right protective equipment, N95 mask, for example, is critical. Face shield is critical. Be fully geared, I think, is critical. Having materials that is impenetrable, things that actually water does not go through it, would be critical. And I don't really know about if the Japanese hospitals have that or not. But probably not a bad idea for at least few hospitals here to have it.
Okay, any other questions? Yes.
Thank you for the wonderful briefing. I'm Kaori Ishikawa, coming from a think tank called the Japan Forum on International Relations. My question is about the education, which you mentioned in Africa. And I've lived in Africa for years in my past. Now, I've read somewhere an article saying that in Senegal, education of mass in the two large cities was a good reason to contain and prevent the outbreak. Do you use, or if maybe not you directly, but those health workers, Western or say industrialized countries, health workers in Africa, do you get in touch with witch doctors and fortune tellers? I did when I was in Africa.
Yeah.
Because they don't listen to us, but they do listen to them. And that's my question.
So actually this is a good area to discuss, because at the World Health Organization, they actually had a session specifically how to engage the witch doctors and other elders to be able to actually communicate with the patients and communicate with the family of the patients through them. So that's a great way of actually getting acquainted and getting the community to buy in what you're trying to tell them. So I agree with that.
Any other questions? Is there? Oh, okay, over here near the front, in the middle, and then. Yeah.
Thank you very much for a very informative lecture. My name is Nunome from African Society of Japan. My question is, Western Africa perimeter areas, there are many, terrorist groups having conventional arms. As you say, Ebola and other HIVs could be bioweapons, and also there will be other outbreaks. There will be, you mentioned. How are you observing such danger, possibility? The terrorist groups acquire Ebola as weapons.
So I think if the question is, would you have some bad people in Africa that are trying to obtain Ebola virus or other bad viruses to be used as a bioterrorist weapon, I think the answer is probably yes, they are. How do you stop them? I don't know how to stop them. I don't know how you can actually stop them from getting the virus. I think the best way to stop them is making sure the outbreaks are limited, outbreaks are quickly extinguished, or there are no outbreaks. So for example, in the case of Ebola virus, I think if you understand what the reservoir is, you can probably control the infection before actually it gets going. So beyond that, I think politically how you can deal with it, that's beyond what I can comment on. So.
Okay, at the back here.
Thank you for your talk. My name is Sarah Abe. I'm at the University of Tokyo. This is a question from the beginning of your presentation, so I hope we can go back a little bit. But you showed us the map of the neighboring countries. And in Nigeria, for example, there were very few cases and they managed to get it under control very quickly. And I heard in the past that they used their polio team to implement some of the methods that work well, like contact tracing, and their case fatality rate was much lower. So I was wondering if you could elaborate on that a little bit more, and also in the future, because there will be outbreaks in the future, how other countries can adapt some of these methods.
Yeah. So maybe a good example of this would be Uganda, for example. Outbreaks happens in Uganda actually very often, but since they have seen the outbreaks over and over again, they can quickly actually identify and quickly they can trace the individuals and who they've been in contact with. So contact tracing actually in Uganda is well established too. And because of their infection controls and because of the training actually they've been receiving, the Uganda outbreaks tend to be very, very small. And I think that was really the case. In Nigeria could have really got out of hand rapidly. But I think they employed like 60 or 80,000 people to do contact tracing, and they quickly brought it under control. So, and their infrastructure, you got to realize, Sierra Leone and Liberia, their infrastructure really been decimated for the last 20, 30 years with civil war. And you saw the numbers there. For every 300,000 patients, they only got 4 doctors to begin with. Actually, last 10 years, I think they've been producing maybe about 2 or 3, maybe 4 doctors a year. That's not a good number. And most of them actually been leaving the country.
Okay, thank you for that question. The next question, if there is some comments from Professor Shapiro.
2 quick questions. First of all, you mentioned that there are many vaccines or therapeutics. Which one is the best? I know it's very difficult to answer, but your speculation perspective. The second question is very simple. In Japan, there's a huge anti-BA4 facility sentiment. It's really hard to convince the people and to let them understand the importance of BA4 facility. You have 2.
There's about 5.
Here we're supposed to have 2, but offshore it's not yet active. So what would you recommend to the Japanese government to convince them? It's a very difficult question. But
yeah. So let's see. So first you asked me about something about the vaccines and therapeutics, in general. So there are unfortunately not a silver bullet that it's out there right now. T705, it's been introduced against influenza virus, And influenza polymerase is very different than Ebola polymerase. So it tends not to be as active against against Ebola virus as it is against influenza virus. But as I told you, that we do see dose-dependent viral knockdown with T705. So it's a promising agent. It really has a long way to go. But besides this one, there's another one called BCX4430. This is another small molecule that's coming out, and that could have some activity against Ebola virus. I think the bottom line is in Africa, biologics actually they're going to be probably cost prohibitive. But antibodies are expensive. At best, they would be about $1,000 per dose. So that's going to be very expensive for them. What you want is a fairly cheap and inexpensive, easily available, that you don't need -80 freezer for storage. So this would be really small molecules, direct antibiotics. In the case of vaccines, right now, live replicating organism is the one that's actually moving forward. This is mainly vesicular stomatitis virus. That was the only one that was available that showed protection in non-human primates, and GMP lot that was available for it to go forward. That doesn't mean that is the best vaccine. That is a live attenuated, so you can imagine you're probably going to have some side effect with that. A lot of Africans are already infected with a lot of agents such as malaria, leishmania. So infecting them with another agent may or may not be a good idea. I don't know. Till somebody does really expanded phase 2 studies in Africa, they won't really know the answer to that. The one that I like, because I've been working with it, and it came out of my lab, is a virus like particles, obviously. And that has actually a little bit to go because it's still in it's close to phase 1, but it's still in the clinical stages. Beside that one, I mean, there's a chimp adenovirus that GlaxoSmithKline and NIH has been working on. They introduced it in Africa to start doing phase 1 clinical studies on it. So this seems like to be promising also. So there is a lot of vaccines and therapeutics that are coming up, but till we really do a true expanded phase 2, phase 3 clinical studies, you literally won't know which one of them are efficacious in human beings. Now you asked me also about the BSL-4 issues within Japan. So it's a difficult area to touch on, but I think it would be important for Japan to actually have BSL-4 labs. I think that's given, because these kind of outbreaks happen a lot, and if Japan wants to be part of the bigger world, then they need to be participating in the research of it also. So obviously there's a lot of cooperation between Japan and the United States in working on these viruses. And I hope they continue to expand. So, but I think I don't see a reason why Japan shouldn't have a BSL program.
Thank you. 日本語でも質問結構ですね。遠慮しないでどんどん質問して。あとちょっと早めに終わりますけど、あと10分ぐらい Q&A のセッション取りますので、どんどん遠慮なくこの際ですから質問してください。
Okay, just here down.
I'm Nakata from National Center for Business. Just I want to know about the cause of death. I have in many cases, first symptom fever, headache, and after that they develop gastrointestinal symptom like diarrhea or vomiting. So they have sometimes daily 5 liters, 8 liters, 10 liters vomiting. So some cases they die of hypovolemia. So that's true.
So everything you said was true. So after talking to lot of the docs who take care of the patients, especially the MSF folks. And at the University of Nebraska Medical Center, it seems like it's not unusual for patients to actually be vomiting or have diarrhea almost 10 liters a day. So, and in the field, that's very, very difficult to replace. So hypovolemic shocks, it's now tend to be one of the main areas of why patients die. And kidney failure is a big area, renal failure, and renal dialysis. The need of renal dialysis was huge. For example, a case in University of Nebraska Medical Center, the patient who died. And liver failure is right next to that.
Also, you mentioned about the cause of this no immune response. But however, for 50%, more than 50%, they recover. It means they have response.
Absolutely. Absolutely. So even in the patients who actually fail, they still have an immune response. The problem is that the immune response can't really catch up with the viral load. When it catches up, things change. The patient survives. So
it depends on the personnel or other reasons.
It probably has a lot to do with the patient to begin with also. If the patient was already infected with multiple other viruses and bacteria, and their innate immune system was already down, their food intake's been very low, and they've been already starving, I think they probably got a lot less chance to make it than somebody who's very healthy. So,
thank you.
Sure.
Okay, I think this lady over here had the next question, so we'll give her the microphone, please.
Thank you very much for your presentation. I'm Yuan Hu. I major in pharmaceutical science. I have one question about the way to protect Ebola. You mentioned that one of the most powerful potential way of protection is to use vaccine, but also in the presentation there was a mention about inadequate use of needles of doctors and healthcare workers. And if needles were used inadequately, it will lead to the outbreak of other viruses such as HIV. So I'm wondering how to instruct doctors and healthcare workers to use needles adequately or other medical devices.
The practice of actually bleeding patients constantly is probably not a good practice in these cases at least. They have to keep that down to minimal, and disposal of the needles is very, very important also. Because after they use the needle, most of the time if they don't have a real box that they can put it in, it goes in that pile. Remember the pile that I showed you? It goes in this pile. Yeah? And then the person who comes by to take the pile, they stick themselves with the needle. Now they're infected. And if you actually stick yourself with the needle, or if you reuse the needle on somebody else, the chance of that person surviving is zero. They tend to die. Because you're bypassing all your innate immune reaction against the virus, and you're directly injecting the virus.
Okay, so we'll have maybe time for one or two more questions. So I think this gentleman here has been waiting. So.
Thank you for your presentation. My name is Shota Furukawa, a sophomore of the University of Tokyo. It may be trivial, but let me ask you. As you mentioned, the natural reservoir for the Ebola virus has not been yet detected, but there are many candidates. So what makes it difficult for researchers to detect it, and why do you think that the snake is a prospective candidate?
So that it's a good question. Why do I think snake is a prospective candidate? Is because apparently snake cells, they get infected by Ebola virus and they tend not to die. So other cells from other animals, they tend to infect it, but they die. So that tells me the virus can actually replicate those cells without killing the cells. That's just the one indication. The other indication is the caves that I was telling you about, python caves. So that's where the pythons actually eat the bats. So that could be another indication. Now, it may not be one reservoir. It could be multiple reservoirs also. Mice can be another reservoir. We selected snakes to look at snakes right now because of some of the criteria that I just told you about. But we won't really know if it's snakes for sure or not until we actually do the studies. And you can imagine how we have to do the studies. We have to take the snakes in BSL-4. We've never done that before. So we've had actually our veterinarian cares. They were very concerned about us taking snakes into BSL-4. We are not really set up to do snakes, so that by itself was very interesting. We have to actually learn how to manipulate the snakes in BSL-4 labs, how to inject them, and then the virus can replicate in them, we'll see. If the virus replicates in them and it doesn't kill the snakes, I think snake could be one of them. That doesn't mean snake is the only one, by the way, because I don't think so. I think there's multiple reservoirs.
Thank you.
Sure.
Okay, next question, if we have one. Do we have, okay, at the back here, yes.
There's one
Oh, sorry, you were waiting, weren't you? It's okay. All right.
Thank you very much for your presentation. Infectious diseases and other invisible threats.
Sorry, excuse me, could you?
Yeah, my name is Oscar Gomez from JICA Research Institute. Infectious diseases and other invisible threats have important impacts socially and economically. According to the World Food Program, now there is a threat of food insecurity or famine in these three countries because the markets are not working. The people have fear of moving on food and moving and trading. I suppose that you cannot advise how to recover that trust in the society, but I wonder if you have perhaps some role advising the army and the people of the embassies of the United States going back to those countries in a gesture of giving back trust to those societies. It happened the same during Fukushima incident in Japan. Embassies and people and CEOs from the companies moving out of the countries because of fear of not understanding what was the effect of radiation. So I wonder what is your position on that?
You got to realize I'm a scientist and I'm not a politician. Okay? Well, to be honest with you, as I told you, really transmissibility of the virus is very, very negligible. And I don't see any reason why U.S. embassies should really go back as soon as the epidemic sort of is getting under control. And I hope that's not the policy, but again, I don't make the policy. So, and but you know, there's a concern about flies. You know, there's people actually flying through Liberia and Sierra Leone into Western world in general. So, and I think that stigma needs to really be dampened too. It's not just the U.S. Embassy and other embassies doing, but even the stigma about having people flying over from these countries.
Okay, for our last question, we're going to come back to you so that you can.
Good evening. Sorry. I'm James McCormick with the United States Embassy here in Tokyo. And my question
So he's a politician, he can easily answer.
I only play one on TV. My question is, looking forward, hopefully in fewer months versus longer, I'm wondering what things might be like once the epidemic has been controlled. You had an excellent slide earlier showing just how few medical professionals were in these affected areas. So having that combined with fatality rates, we're getting lots of support from around the world, to include Japan, the United States, and many other countries, sending medical professionals there to help. But once this is all taken care of, it's going to be in a very precarious state. Do you have the sense that the world writ large has a sense that our work really won't be done there once we've dealt with this outbreak?
Yeah, that's a great point. I think their infrastructure, health infrastructure has been totally decimated for years of civil war. And that has to be rebuilt because Ebola virus has really brought it up. And as I told you, that's probably not the last epidemics that these three countries are going to see. So if their infrastructure is not really replenished to the state that I would say, I think it's pathetic to have one doctor for every 100,000. And those doctors weren't really even trained well enough to deal with these type of epidemics. So I think building the infrastructure in these countries is critical. Otherwise, US and other countries have to deal with this for a long time to come. So we have to really help them to stand on their own feet. I don't know if I answered your question or not, but that's my view. I don't represent WADAD, so.
Okay, thanks everyone for an excellent question and answer session. We're going to finish with some remarks from our co-host, the Japan Society for Africa, from Mr. Morokoshi, please.
Good evening, everyone. This is such a pleasure hosting this wonderful seminar tonight. Thank you so much for coming, everyone, tonight. I would like to thank Professor Shibuya, JIGH, and University of Tokyo. I and Professor Shibuya barged to Maryland 2 weeks ago to see Dr. Bavari. And we actually met at the Burger King in Fort Detrick. And he's been so much more than kind to come to Japan to deliver this wonderful seminar. And
actually, hold on. Let me tell you the full story because we're getting a lot of it. I get this very strange email that we like to talk to you, and a few Japanese names shows up, and I don't know any of them. And the person who was with me, my program manager, she said, just delete it. I said, no, it could be important. She said, is this what you typically do? You go around and talk. I said, not typically, but it's like 4 of them. How bad could they be? So, and next thing I know, I got like 10 emails that keep coming, that we're coming to Fort Detrick to see you. And I said, well, they're a bunch of Japanese, they're not going to get into Fort Detrick. So I wasn't worried about it. And the next thing I get is an email that we are in Burger King's waiting for you. So I couldn't really refuse the offer, And they had a bag also, a bag of compounds. So that was really interesting for me. So actually, I'm glad I took the offer. So go ahead. I'm sorry, I didn't mean to stop.
And he was kind enough to offer as a double offer, and we didn't take it because we are kind of nervous because that's a kind of place like that. It's hard to get into, but he's really more than kind enough to come to here to deliver his insight tonight. And Sina, thank you so much. And maybe you owe me a double offer for this.
Yeah.
A small gift from us. And once again, please give it up for Dr. Bavari and Professor Shibuya. Thank you so much. Maybe we are sure that we will conquer Ebola virus disease pretty soon. And we We need to bless Africa. We love Africa. And anyway, thank you so much. Thank you so much.
Okay, thank you everyone for coming tonight. That's the end of our seminar, so thank you very much.